Here we are, back again, lesson 4.4. Our objective today in using the slope formula is to find slope by using the formula by looking at functions, graphs, and tables. So starting on page 254, the slope formula. You guys have talked about rates of change and slope as far as rise over run. This should say in lesson 4.3 instead of 5.3. Slope was described as the constant rate of change of a line because the line has the same slope no matter where you are on it. You saw how to find the slope of a line by using its graph. There's also a formula that comes in handy, usually represented by the letter M. When we talk about slope in a formula, its place is held by M. And that's because we've talked about the French word monter, which means to ascend. That's where the M came from. To use this formula, you need the coordinates of two different points on the line. So here's three ways of looking at slope. It's the ratio of the difference in y to the x values. That's what we talked about in 4.3, change in y over change in x. And if we have the 2 points, it's again the change in y, or the difference, which is simply subtraction, over the change in x. y2 minus y1 over x2 minus x1. And here's an example of how to use it. If we have these 2 points, the change in y, 4 minus negative 3 over 1 minus 2. If 4 is first in the numerator, 1 has to be first in the denominator. And we simplify that as negative 7 over 1, which is just negative 7. So let's have us try this problem. Find the slope of the line that contains the point 2, 5 and the other point 8, 1. We're going to use our formula, which says slope M is equal to the difference in y over the difference in x. And we're going to substitute in our values. It says 2, 5 is going to be our x1, y1, and 8, 1 is going to be our x2, y2. This doesn't matter. I could switch x2, y2 is this point, and 8, 1 is this point. It doesn't matter, but we do have to keep track once we decide. So the difference 1 minus 5 over the difference 8 minus 2, we simplify to negative 4/6. Simplifying further, we get a slope of negative 2/3 between the point 2, 5 and 8, 1. This is in simplest form. We always want to leave our slope in fraction form because that tells us the rise over the run. So you guys try check it out, number 1A. Come on back and check your answers. So we're going to plug in our values. I see a negative 2 value for y and another negative 2 value for y. Let's see what happens when they're the same exact value. Substituting in, notice they've said negative 2 is x1, y1. This is the second point, x2, y2. So negative 2, take away, it's always take away, another negative 2. We have negative 2 plus 2 over 7 minus negative 2. Negative 2 plus 2 is the same as 0 over 9. And we remember that a slope of 0 indicates a horizontal flat line. The slope of this line is 0. Let's try check it out. 1B. Find the slope of this line. They've designated points x1, y1, 5, negative 7, and x2, y2 is 6, negative 4. Substituting those values in, y2 is negative 4 minus y1, negative 7. It's subtraction again, so it's negative 4 plus 7 over 6 minus 5. And we simplify to 3 over 1. Leaving it as a fraction, a unit fraction, we can see our rise and our run. Sometimes 3, a slope of 3, is confusing because we don't know how far to run. It's always 1 when our numerator is a whole number. Now, what about fractions? Well, it's the same exact thing. We're going to identify which point we want for x1, y1 and x2, y2 and simply substitute into the formula. They have used 2/5 for y2 minus 7/5 simplifies to negative 5/5 or negative 1. And in the denominator, 1/4 minus 3/4, negative 2/4 which is negative 1/2. We're asking how many halves are in one whole thing. The answer is 2. So our slope would be 2. Sometimes you're not given 2 points to use. You might have to choose 2 points from a graph or a table. Let's see what that looks like. So here we're given the table. Once again, remember, we can calculate rise. I see a rise of 4 and a run of 2, but we can also use the formula. And since we've just learned the formula, that's what they want us to do. But we can check our answer by just simply looking at the graph. Making sure they're doing their math correctly, our slope is positive 2. The other thing that might happen is this. You're told that you have a linear relationship. Now find the slope. Well, all of these points fall on the same straight line. Therefore, between any 2 points, we have the same constant rate of change. So let's let 0, 1 be one of our points and negative 2, 5 be the other point. We simply use the slope formula by plugging in. And we get 5 minus 1 over negative 2 minus 0, simplifying to a slope of negative 2. Let's try check it out 2a. It says the graph shows a linear relationship. Find the slope. Again, it doesn't matter which point you choose first, but we want to check our answer by looking at the graph. It says y2 minus y1 over x2 minus x1, and we simplify to 1/2. Now I want to check my work. It's rise 2, run 4, and 2 over 4 simplifies to 1 over 2. So we know that we've done the math correctly. First thing I want to observe in a problem like this is the negative slope. When I get done using my slope formula, I want to make sure that my value is negative. I know the slope is negative. I want to make sure I did my math correctly by checking the negative slope. So they've plugged in the points negative 2, 4 and 0, negative 2. Simplifying, they get negative 6 over 2, which is a negative 3 slope. Let's check to make sure that's correct. Down 3 over 1, down 3 over 1, negative 3 slope. Let's look at this table. It says it shows a linear relationship. So therefore we can pick any points we want. I always like to pick the simplest ones to do mental math first, and then possibly pencil and paper. 0, 1, and 2, 5, fairly easy. The difference between 1 and 5 is 4. Difference between 0 and 2 is 2. And we should come up with a slope of 2. Making sure that y is on top and x is in the denominator. Let's try this one. Anytime I have the point 0, 0 or the origin in the problem, I always use it. It makes life really simple. The change in y, we can go either way here. The change in y from point 2 to point 3 is down 3, while the change in x is up 2. Negative 3 over 2. We could go backwards as well. From 0 to 3, we went up 3. From 0 to negative 2, we went down 2. Still simplifying to negative 3 over 2. Thing to remember is that slope is a rate of change. In real-world problems, finding the slope can give you information about how a quantity is changing. Let's look at example 3. It says the average electricity cost for operating a refrigerator for several months is given. Find the slope of the line and tell what it represents. Well, we can simply use our slope formula. From here, I can see from 12 to 24, we went up 12. And from the x quantities, we went over 2. So negative 12 over negative 2, or positive 12 over positive 2, yields a positive 6 slope. Our objective is to be able to explain what that means. The change in the y-axis is the cost of electricity. So if we have a positive change of 6 over 1, the x-axis is months, while the y-axis is electric costs. We see that ours is the change in cost over the change in time. $6 per month is our rate of electric costs. And for this one, we see height and we see time. The height of a plant versus time. So from this first point, 30 days over 10 centimeters. And here we have 50 days and 20 centimeters. So let's use our slope formula. Plug in those values. They have taken y2 to be the bottom point and y1 to be the upper point. So y2 minus y1 over x2 minus x1. And we have a slope of 1 over 2. Remember, that's the change in the y, or the height, over the change in days. So we can conclude that the height is changing 1 centimeter and the days are changing by 2, meaning 1 centimeter every 2 days or 1/2 centimeter every 1 day. If you know the equation that describes a line, you can find its slope by using any two ordered pairs solutions. It's often easiest to use the ordered pairs that contain the intercepts. So in example 4, it says, find the slope of the line described here. Well, we know to find the x-intercept, we're going to let the y be 0. When that term cancels out, we have 4x equals 16, so x equals 4. We're going to find the y-intercept by doing something similarly. We're going to let the x value be 0. And we're going to calculate the y-intercept. When x is 0, this term cancels, and negative 2 times negative 8 is 16. Understanding the two values, the line contains these 2 points, using the slope formula suddenly becomes very easy. We have a y minus 0 and a 0 minus our x. So we have a very simple calculation, negative 8 over negative 4 for a slope of positive 2. Let's do that again with this one. Find the x-intercept by allowing y to equal 0. Find the y-intercept by allowing x to equal 0. And then substituting those coordinates, 0, 4, and 6, 0, into our slope formula. So go to PowerSchool. Please find our lesson, our assignment for Lesson 4.4, and we'll see you tomorrow when we talk about direct variation.